Welcome to the DIY Honda Garage channel. The error code P0713 indicates an issue with the continuously variable transmission, CVT, fluid temperature sensor, specifically relating to an open circuit. This diagnostic trouble code, DTC, suggests that the electrical circuit related to the CVT fluid temperature sensor is having a failure, and it is crucial to note that this code is not due to mechanical defects within the transmission system itself. The CVT fluid temperature sensor plays a critical role in monitoring the temperature of the CVT fluid, which is important for proper transmission operation. If the fluid becomes too hot, it can affect performance and cause damage. The sensor is typically located near the CVT and is connected to the vehicle's engine control module, ECM, and transmission circuitry. Understanding the nature and source of the issue is fundamental for accurate diagnosis and proper repair. The CVT fluid temperature sensor is designed to measure the temperature of the CVT fluid, ensuring the transmission operates within efficient temperature limits. This is significant, as consistent temperature monitoring can prevent overheating and prolong transmission life. The sensor is located in close proximity to the CVT, usually integrated into the transmission housing. Its primary connection is to the engine control module, ECM, which processes the sensor's data to adjust transmission performance accordingly. When DTC P0713 is triggered, it implies that the signal from the temperature sensor is not being received properly, causing a potential risk of inappropriate transmission behavior. Diagnosing this issue is essential to maintain optimal driving performance and vehicle reliability. There are several potential causes for the P0713 DTC. First, an open circuit in the wiring harness connecting the CVT fluid temperature sensor to the engine control module, ECM, may result in a broken signal, leading to the error code. Second, the CVT fluid temperature sensor itself can be defective, which would necessitate its replacement. Third, there might be a faulty connection at the powertrain control module, PCM, impacting the overall communication and data exchange between components. Lastly, general wiring issues, such as shorts or breaks in the lines leading to the sensor, can also invoke this code. Each of these causes necessitates careful inspection to identify and rectify the underlying issue. Symptoms associated with the DTC P0713 can vary, but typically include noticeable transmission performance issues. Drivers may experience unusual shifting patterns or behaviors, as the transmission struggles to react appropriately to the engine's demands. Overheating can also be a significant concern due to improper or erratic temperature readings from the fluid temperature sensor. Furthermore, the error will appear in the onboard diagnostic system, prompting the need for technical inspection. Ignoring these symptoms can potentially lead to more severe damage or failures within the transmission, making it crucial to address them quickly and appropriately. In the first troubleshooting step, the technician needs to turn the ignition switch to the on position, which effectively powers the vehicle's electrical systems without starting the engine. After this, the HDS or Honda Diagnostics system is used to check the voltage from the CVTF temp sensor. If the reading indicates 4.93 volts or more, it suggests that the failure has been duplicated, allowing the technician to proceed to the next step. However, if the voltage does not meet this threshold, it indicates a potential intermittent failure. In such cases, technicians are advised to refer back to any freeze frame data or onboard snapshots recorded when the DTC was triggered to try and recreate the specific conditions under which the failure presented itself. The second troubleshooting step requires turning the ignition switch to the off position to ensure safe disconnection and avoid damage to components. The next action is to disconnect the 8P connector from the solenoid wiring harness, which is essential for isolating the problem area. Subsequently, using a jumper wire, terminals A and B are connected together to create a temporary circuit. The technician then turns the ignition back to the on position and again checks the CVTF temperature sensor reading via the HDS. If the sensor now indicates a value of 0.07 volts or less, this suggests a fault in the sensor itself, prompting the technician to move to the next step. Conversely, if the voltage reading is higher, further diagnostics are necessary. During the third step, the technician must first turn the ignition switch to the off position again before proceeding. The jumper wire used in the previous step is then removed to restore normal functionality to the sensor. Next, terminals A and B are connected in a different configuration, specifically connecting the solenoid harness to check if the CVTF temp sensor is functioning correctly. After that, the ignition is turned to the on position yet again. This time, if the sensor registers 0.07 volts or less, the sensor itself requires replacement, as it is not providing accurate data to the PCM. On the other hand, if the voltage is above this threshold, there is likely an open in the SG2 wire, necessitating further investigation between the wiring and the PCM. The final troubleshooting step involves confirming the integrity of the wiring itself. Once again, the ignition is turned off for safety before jumping the SCS line using the HDS. The technician will then need to disconnect the PCM connector labeled B, which has 51 pins. The check for continuity between test points becomes crucial at this stage. Continuity tests involve verifying that electrical signals can successfully pass through the intended paths without interruption or resistance. Specifically, in this case, continuity should be checked between the solenoid's harness and the PCM through the TATF wire. If continuity is confirmed, this suggests the wiring is intact, leading to a potential need to update the PCM software or replace the unit if the fault persists. If continuity is not found, the technician must repair or replace the TATF wire to restore proper operation. Following the completion of all necessary repairs concerning the P0713 DTC, it's essential to verify that the repairs were indeed successful. Technicians should begin by checking the onboard diagnostic system to see if the DTC still appears. Clearing the DTC and performing a test drive is a critical next step, allowing for real-world evaluation of the vehicle's performance and transmission behavior. While on the test drive, it is essential to monitor for any symptoms previously reported, indicating whether the issue has been resolved. If the vehicle performs smoothly without triggering the DTC again, the repair is confirmed successful. This final verification helps ensure that the vehicle is in optimal operational condition, ready for safe driving. To prevent future occurrences of DTC P0713, implementing a scheduled preventive maintenance plan is highly beneficial. Regular checks of the transmission fluid should be part of routine vehicle care, as maintaining appropriate fluid levels and quality helps ensure that the transmission operates efficiently. Additionally, monitoring temperature readings from the CVT fluid temperature sensor can preemptively indicate if issues are arising. Inspecting wiring for any signs of wear or damage consistently can also help mitigate electrical problems that lead to faults. Furthermore, ensuring that the powertrain control module, PCM, is updated with the latest software will optimize the transmission's performance and reliability. Following these practices can significantly enhance the lifespan and efficacy of the vehicle's transmission system. In conclusion, the P0713 DTC reveals crucial information regarding the functionality of the CVT fluid temperature sensor and highlights the importance of timely diagnostics and repairs. Electrical circuit faults are the primary cause of this diagnostic issue, emphasizing the need for thorough testing of connections and sensors. Understanding the role of the CVT fluid temperature sensor in maintaining optimal transmission performance is vital for every vehicle owner. By proactively monitoring engine and transmission parameters, and by being aware of the potential symptoms associated with such faults, vehicle owners can take corrective action before problems escalate. Finally, adopting preventive measures can protect against similar future issues, ensuring smoother and more efficient operation of the Honda Civic. Please like and subscribe to the channel. See you next time.